Hi everyone, this is Chemistry News Selection Channel. My name is Greg, and today I'm going to talk about 3D printing and injection molding of glass. Humanity used glass for like thousands of years. And believe it or not, the technology that is used today to make products from glass did not significantly change in those thousands of years. So what do you have? You still have this blowing, you still have the forming of the glass. You have to melt it and then put it in the form, make, Coca-Cola bottles and stuff like that. Well, maybe the more advanced molding you can see here, again, you just make a template, you melt the glass and put it in the template while you continuously heat it. It requires like 2000 degrees and still you cannot make many parts. Still, in many places it is easier to work with plastic, which we now try to use plastic less. And even in some places where using glass can be superior due to glass rigidity, due to its thermal stability, still people use plastic because it's just hard to make very fine forms from glass. So a group from Germany tried to resolve the challenge by making from glass something that was before possible only with plastic. That is the 3D printing and injection molding. And the first paper about 3D printing came out in Nature in 2017. And the idea which they explored was the following. So how you 3D print glass? They wanted to incorporate glass particles in a polymerizable monomer matrix, which you can 3D print. So you basically use composite materials of glass and plastic. Then when you make this material, you 3D print it in the normal 3D printer, and then you heat, and while removing the plastic part of the composite, you fuse the glass particle to form a solid glass. Monomer and common 3D printing plastic, and they used amorphous silica nanoparticles with 40 nanometers diameter in average. This silica is basically microscopic glass particles, and it's used in chemistry for many purposes, mainly for chromatography, for separation of materials. By the way, about 3D printing, I had a previous video. It was in Russian, but I think there are English subtitles, so you can check it. They did experiments to incorporate these nanoparticles in the monomer, to use as less as possible of the monomer and as much as possible of the glass, and eventually they were successful. And that's the video that they attached to the Nature paper. So you can see they put the composite material in the 3D printer, they 3D print the structure that they want. You see, they put it in the oven, then they heat it, the monomer evaporates, and here on the side you can see the glass particles, and they fuse after more heating time. The size is reduced a little bit. Those are the structures. Beautiful, right? And yes, that's how it's shown schematically. You incorporate the silica in the monomer, 3D print from the liquid, you polymerize those regions, slowly raise it, and then you form the structures. This picture here demonstrates what level of fine-tuning can be achieved here. Amazing stuff. I mean, that's something that you could do before, perhaps, again, not with this level of precision, but by maybe chemical etching with hydrofluoric acid, and believe me, you don't want to work with hydrofluoric acid. Amazing proof of concept. One of the things that can be improved is that they can perhaps do some plastic that can be collected and reused. Another thing that can be done with plastic and cannot be done with glass is injection molding. Basically, just majority of plastic things that you used were done by injection molding and not by 3D printing. The same group published paper now in Science, very recently, 2021, very fresh work. The idea is somewhat similar, but not 100%. In 3D printing, you can use the liquid substrate. For injection molding, you need to make solid particles, then melt them, inject them, and then make them solidify. So this project was definitely more complicated, and cannot even imagine how many experiments were dedicated to develop this particular composition. What they came up that 2 polymers are needed here. So they used this polyvinyl butyrol and polyethylene glycol. By mixing them at mild temperatures, they could make granulus, the feedstock for the injection molding. Then they did the injection molding. A nice thing that they could do, they basically, by adding one step, they were able to remove one of the polymers, the polyethylene glycol, to debind it with water, and they could later reuse this polyethylene glycol, so partial recyclability of the process was achieved. Then polyvinyl butyrol is destroyed, and then they do the sintering to make fused silica, basically injection molded glass. Again, they could reach very fine structures here. These are the examples, a third of the millimeter resolution, amazing work. Again, something that was hardly possible before, especially in such relatively easy and scalable process. They present here one of the applications, which is making a microreactor in which you mix microscopic amounts of some reactants, and they react here in this groove. Okay, so again, those things were done before only with polymers, not with glass. However, not every reaction can be done in a polymer reactor. Sometimes you need glass reactors. That's why people use glass lab equipment. So now you have a microscopic glass lab equipment. Thanks for your attention, and sorry I forgot to mention, all the links to the original publications are in the description below. Goodbye.